This is an idea which is really big, very important in statistics. And this is the idea of something called the sampling distribution. The sampling distribution is what happens when we're taking samples. If you think about the idea of what often happens in statistics is that we have a population of values, and I'm going to use X's for those things, okay? So I have a bunch of X's. This is my population. But then I also am going to be taking samples. And what I want to do is I want to take some group of this, and I want to take the average of a bunch of these X's. So when I take the average of some of these X's, then I'm going to get a sample mean, X bar. But then if I do that over and over again, then each time I get a sample, I would be getting a different number because I pick my samples at random. And so then the members of the sample are different. So now instead of having a population distribution, which is what I have over here, I'm going to have a sampling distribution. And this is where I have different sample means. And so then the question is, what can I expect from this? This then is my sampling distribution right here. So the sampling distribution, it's similar to the population because it's numbers that are changing, they're different. But there's a specific situation here, and it's explained in the textbook and it's explained in the video, that the mean of these samples is going to be the same as the mean of the overall population. So the middle here is going to be the same as the middle over there. But the standard deviation of those samples is going to be different. It's actually going to be smaller. It's the population standard deviation divided by the square root of n, where n is the sample size. But then the magic here, the big idea, is that this thing, this sampling distribution, under certain conditions, will be bell-shaped. And if this thing is bell-shaped, then that means we can use our technology to figure out what to expect in this situation. But we have to be careful because now we're looking, the mean is the same, but the standard deviation is different, so that when you're figuring out your z-scores, you won't use the population standard deviation. You will use this new one for the sampling distribution. All right, well, there's a lot going on here. I recognize that. And I hope that this little exploration has been helpful for you so that you would know what kinds of things that you'll be working on. And of course, as always, if you have any questions about anything, feel free to let me know. And certainly you can contact Julia in the Online Math Center. She knows how to work with these kinds of problems as well. And best wishes.